Hello, peace and blessing to all you hardworking students out there who are making hard effort to learn data analysis and following my channel for this regard. In this presentation, I'm going to discuss the structured query language, in short, SQL, right? By now, you have been able to perform some basic SQL queries against PostgreSQL database. But today, I thought about dedicating a presentation to talk about the conceptual understanding of SQL and how it really works with the relational database management system. So without any further ado, let's get to the introduction of this presentation. So I'm going to first talk about the structured, semi-structured, and unstructured data. And then I'm going to talk about the SQL language, what it actually does and what are the standards. And then I'm going to talk about the goals of SQL, right? Overall goals of SQL. And then I'll touch upon some of the main query categories of SQL, main SQL query categories that you need to know. And then lastly, we're going to talk about the relational database management system and some of the most famous service providers of the relational database management system. So let's start. Structured versus semi-structured versus unstructured data. So as you can see, I put structured and semi-structured in one category, and then I put unstructured data in unstructured in a different category, right? That's because up until a few years ago, in a lot of academic and also the next generation data analysis uh, uh, modern practices, right? You would have seen that the data in terms of their structure were divided into structured and unstructured data types, right? But lately, because of the evolution in the data ecosystem and the modern practices and modern database management systems that are improving on such a fast pace, we have had a third uh, data type in terms of structure called the semi-structured data, right? So I've also included this in here, and I'm going to talk about this while discussing the structure of data overall. So let's start with the structured data. So structured data, as you can see on this table here, and also here, is nothing but a type of data structure that has a predefined data model, and it's pretty much a combination of rows and columns. And as you can see here, we have columns. We have 5 different columns here in this table. And we have also rows that each row has its own line of values associated with that one specific line, right? Or row, however you want to call it. And we also have the column, right? So this is a structured data because the data can be mapped by relational database. So a relational database, which I'll talk about in a second, and it's important to it was important for me to talk about the data structure before getting to the relational database management system or relational databases. So structured data can be mapped, right, very easily by relational database. Why? Like for example, if you want to perform a filter on year, and if you want to put all the years associated with year 2023, then you can easily map those data to 2023. That is easy. So it makes it easy to manipulate, to search, to define all that stuff, right? And the structured data it has something called schema. So you probably heard me talk about schema before. So the data and structured data the structured data are schema dependent, which makes it a little bit less flexible because, for example, each table has a schema, and then each table can have dependencies and constraints. So when you have constraints and dependencies, then and also a predefined data model that shows all those relationships, then it's important. Although it's easy for you to search and map the data, but in the meantime, it makes it a little bit less flexible for you to pretty much to use scalability, Because why? Because you have to keep all those constraints in mind while you're making any changes to the scale of your data. So that's something, that's kind of like on the negative side of it. Although on the positive side, as I said, every it has a predefined, pre-established data model. It's text-based, and it has the all the values in terms of rows and columns. Makes it easy to filter, to map them, all that good stuff. Also, before I forget, in structure data is highly is has the highest performance when it comes to querying, right? So if you want to query millions and millions of records from a structured data, for example, if you have 2 million records, right, associated with 2023, a query can be done in a matter of like few seconds, and you can get all that information extracted for you using a very basic query. So that itself, adds to performance of when we are dealing with data, structured data in a structured database system. And then lastly, that's something I must have said earlier, is that it's highly organized, right? So as you can see in this in this table here, that everything is organized. You don't see any redundancy here. Everything is divided in terms of columns and rows, right? So that. And I'm not going to talk about relational database and data warehouses, which is where they reside, because that's something I'm going to talk about in the next slides. But normally in a structured data, the type of data that you'll find is dates, numbers, phone numbers, anything that have structure to them. Now let's talk about the semi-structured data. So semi-structured data is kind of in between, right? It's semi-organized. It's it's the type of the nature of data that are in a semi-structured data, or or not really as organized as structured data, right? It's partially organized data. That's what I can call it, partially organized data. But that you can add to the organization of the data by actually assigning, by assigning structure to it. Now, let's say, for example, as I have given you examples here, for example, if you have emails which are by category, sorts, etc. Now, let's say if you want to extract the metadata or meta level data from these emails, then you can actually extract information that may not be as organized, right, and as mappable as structured data, but it's something that you can work with, right? It's something that you can work with so that you can analyze them. So just because a data is semi-structured, that does not mean that you cannot analyze the data. So you can do something in the background or the transformation of these data to make it analyzable, to make it mappable, to make it definable. And like, just let's say another example could be transcripts, right? Transcripts are like nothing but a series of words and letters. So you can work with transcripts to, let's say, put them in chunks or blocks of data, and then perform analysis based on that, or let's say survey answers, right? Or so to say social media posts such as tweets. So social a tweet could be, let's say, only a few sentences, but you can there's still a partial organization, right? It's partially organized data that you can perform some analysis. Let's say, you can do text analysis, you can do sentimental analysis, you can do some sort of, let's say, word-based analysis. Although those are words, there's no structure to them, but there are certain things that you can do to those data, in terms of analysis, to get meaning out of that data. So just like the structured data, the semi-structured data also resides in relational databases and other types of database, which I'm not going to talk about a lot in detail in this presentation. And also remember that semi-structured data is more flexible and scalable than structured data, because semi-structured data, it's also mappable. It can also be mapped, but the tool or the mapping mechanisms used for mapping semi-structured data is things like XML or RDF. I'm not going to get into details of those as well. And then yeah, and then let's talk about unstructured data, right? So unstructured data is more like on the far right spectrum of data organization. That means it's unorganized data. So there is no predefined data model, right? There's no relationship between tables. There's no table involved. There's no structure involved. There's no relational tables involved. There's no model, right? That kind of stuff. Yeah. So it's very difficult for you to define relationship between data in unstructured data. So it could be text-based, but mostly it's like PDF images, let's say web pages, video, audio files, social media files that don't have a structure to them. So and that makes it difficult to search the in terms of searching, in terms of also because of no dependency on unstructured data is highly flexible and scalable because it doesn't have no dependency. So you can it's very flexible, it's very scalable, so you can do anything you want. But when it comes to mapping, and when it comes to performing any type of searches, then it's almost impossible to do any type of searches, right? Because the data are inside these buckets, right? Or however, for the lack of a better term, that makes it difficult for you to perform any sort of, like, let's say, filtering or any sort of like searches, any sort of manipulation of the data. So but only, however, only textual queries, if it's text-based data, for example, although it's unstructured. Let's say if it's a Word document, although it's unstructured, it's an amalgamation of like words and letters. You can still perform some sort of, let's say, query. Let's say you can do some replacing, you can do finding, that kind of stuff. But when it comes to like highly organized structure-based data analysis, then that's difficult to do. And I'll also give you guys examples. Just in a nutshell, a structured data could be this kind of table. We have years, numbers. Let's say, if you can have dates. That kind of. A semi-structured data could be, let's say, emails, transcripts, survey answers, social media post tweets. And an unstructured data could be things a little bit more redundant than semi-structured data, although they can overlap sometimes, right? It's kind of difficult to define the difference between a semi-structured and unstructured data when it comes to like text-based data, right? Because you could have a transcript is a text-based data, but as a newspaper is also text-based data. So maybe a transcript is, or a survey answer is a little bit more organized than a newspaper where you have 3 or 4 pages of information, and where it's PDF, right? Or it's image that you cannot really convert to the sort of data input that you can do any sort of analysis on. And so example of unstructured data could be video, audio files, social media, images, web pages, records, records and documents, that kind of stuff. And so both semi-structured and unstructured data it resides in databases. Semi-structured data can still reside in relational databases, because again there is some sort of structure related to them, but unstructured data mostly it's like data lakes and data warehouses, which I'm not going to talk about in very details in this presentation. But I think it would be fair to talk about it when it comes to unstructured data and the topic of NoSQL, because that's the language, the no structured query language for no structured databases, which I can cover in a different video. As long as you know these three different structures in terms of data, and that should be it. Let's go to the second topic, which is SQL language. So SQL language is a language, right? So a SQL, I've been talking about SQL forever now. So SQL is a language that we use to manage the data, right? To manage the data in a relational database management system in an RDBMS. As simple as that. So SQL, as you know, stands for Standard Structured Query Language, which it can perform various operations on a database, such as, let's say, retrieval of data, removing and renaming data, updating data, deleting data, managing data. All sorts of operations relate to a database. Let's say RDBMS systems such as Oracle, let's say Microsoft SQL, PostgreSQL Server. These are some of the data. These are examples of some of the database systems that use SQL language. So we can also something that a lot of time people mistake, misunderstand between SQL and a programming language. So we cannot fully call SQL a programming language, but it's SQL is a type of query language that we can use to create like procedures and embed them within programming language to perform certain functionality related to data, if it makes sense. So although it's not fully categorized as a full programming language, but it does work with programming language hand to hand, right? It's more like a programming language for the data. But when we need to let's say create a data flow between an application and a database, then we're going to use SQL inside the programming language that we use just as an extension to extend its functionality for that in that regard. So to understand SQL language, there's no requirement for coding. It's very interactive. It really resembles like command in English. So for example, if you want to get all of the data from a table in a database, and if you say select right? Select, let's say you specify the column names and then you say from this database, then actually that resembles a lot when you make a command to, in like an English language. So, sometimes it can get complicated when it comes to, more advanced procedural scripts. But overall, the general concept of SQL language is to pretty much be simple and easy to understand, and it's also well defined as standard. Every syntax has a predefined standard that you will need to follow and understand in order to be able to pass functional query commands. And lastly, mostly SQL language is used to manipulate databases, but that's not it. I'm going to move uh, to the third slide, where I'm going to talk about the general goal of SQL. So in SQL, the general goals can be five. So it can be divided into five main categories. The first one is that we create a database with it. So if we're in a database management system, we can use SQL to create databases and also create tables. So when I say create database, that means you know all the things that comes underneath a database, which is schemas and tables and columns and constraints and dependencies and structures and data mapping, all that stuff. You can also use it to access database. That means you can access databases, you can provide, and then you can also manage an administrative database. That means you use SQL language not only for creating database or accessing data, but you also can use it as a administrator or manager role, where you use SQL to grant access or revoke access, that kind of stuff. The fourth one is manipulating database. That is where a lot of time. This is where the majority of the SQL commands are invested in or used for, is manipulating database. That means when you're, let's say, when you're performing unions between tables, when you're establishing relation between tables, when you're performing data definition queries, when you're performing data manipulation queries, such as, let's say, you're creating records, you're creating columns, and then you're deleting columns, you're deleting rows, and you're specifying, conditions, you're converting, you're transforming the field types. All that stuff comes under manipulation of database, which is again where majority of our work as a SQL developer or SQL data engineer or data analyst is spent for. And then lastly, you can also use database for applications. That means not only you're able not only you can use SQL to do create, access, manage, and manipulate database. You can also use SQL, as I said earlier, to for data for applications. Like I said, you can use SQL to create, let's say, procedure extensions, pipelines, data flows, all those data-related functionalities inside an application when you program that application. So that is one of the core goals of SQL too. But that's something that you probably won't use too much as a data analyst. That's more like someone who's a software developer who works hand in hand with a data engineer to establish those functionalities, but just wanted to make sure that you know that. All right, let's go to the next one. Categories of SQL queries. I think I have a video of a special I have a video especially concentrated on the main category of SQL queries. Overall, the SQL queries are categorized into five different classes. DQL is pretty much the query language, and the category SQL queries kind of falls under it kind of covers these five general goals that I've outlined here, right? So although here it's just general concepts, here with the categories I'm going to get into a little bit of like mid-level details of what these categories are and what kind of operations you can do with them. So DQL, which is short for data query language, it allows you to perform simple queries pretty much when you want to extract data, like give me this amount of data from this table or from these tables, right? Simple as that. A lot of your time was spent, if you don't have to do a lot of data manipulation or data transformation or any sort of redefining data and data model. You don't have to, with the data query language, you don't have to do too much. It's just you're just picking up data from a table or multiple tables from a database, and you're just dropping them somewhere else, or you're just extracting them. Simple as that. And a data definition language, that's where you're defining, right, the data. You're making, you're making, you kind of performing the type of queries that are defining like your data. For example, you're doing like insert, you're doing like deleting records, columns, working with the columns, that kind of stuff. So next one is DML, the data manipulation language. This is a lot of your conversion comes, you're manipulating the data. Manipulation data can cover a lot of things. You're doing transformation, you're doing unions, you're redefining data types, uh, you're running CTEs, you're running procedure commands, all that stuff. Um and then and so, some of the times you can be using something that so just because you're using one of them, it doesn't mean you're not going to use. Sometimes some of these queries can overlap. So sometimes you can be using a combination of two or more of them, right? So when you're running a script. So keep that in mind. And then data control language is pretty much more like the data, the management and administration of the database, where you're, granting access, revoking access, that kind of stuff. And data control language is more like when you're committing data, when you're, doing rollbacks, all the control related functionalities related to the database. But again, if you really want to see some of the sample queries under each one of these categories, please refer to my videos uh, that talks about the type of or the categories of SQL queries and Postgre and SQL video playlist. So now that we know what the sequels are, right? What the categories of sequels are, what are the general goals of SQL. Now let's talk about the RDBMS, right? The RDBMS is where you're going to perform your SQL. So an RDBMS, which is short for Relational Database Management System, stores data in a tabular form, just like I have the screenshot here, where a column presents a property and each row in a table presents a record or line of data. So the RDBMS systems, store structured data, establish relationship between the data. That's another way to call it. With RDBMS, you can create, read, update, delete, and perform a variety of function operations into the RDBMS database system. So, and SQL is the language that you use to perform all of these, right? So, SQL commands or SQL statements are used against RDBMS databases to 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 attain certain objective, right? So with RDBMS again, it's nothing but a relational database management system, right? Where it has we store the data in tabular forms, right? And it has columns and rows which contains the related data entries. And as you know, columns are nothing but vertical entity of a table, and then it includes records attributes, and rows are nothing but horizontal entities of a data or record. So the intersection of columns and rows as it consists of information of record considering that attribute. So simple as that. Now that we know what the RDBMS are, some of the most famous RDBMS database systems that you need to know are MySQL, Oracle, SQL Server, PostgreSQL, IBM DB2, Microsoft Access, Azure SQL, Informax, and and a bunch of others that I may have not added their names here, but these are the most dominant and next generation modern database management systems, relational database management systems that are very common. That if you start a job as a data analyst, a data scientist, data engineer, you're most likely to work with one of these relational. If you work in relational and with structured data and relational databases, it's you're highly likely to be working with one of these. Although Informax is a little bit outdated, but definitely SQL Server, Oracle, PostgreSQL. These are the ones, and also MySQL. These are the ones that you should really expect, from among the famous RDBMS databases to work with. This is it. I hope that I have covered everything that you need to know about SQLs and the relationship between SQLs and the RDBMSs. Thank you for your time. I will see you guys in the next video.